I'll be talking about how research has been brought into creating the different interactive AR learning experiences. And to give a brief about why this particular research area was taken up and how was it taken up. I'll first start with what our design lab is all about. I am part of this immersive media experience design lab at IDC School of Design, IIT Bombay. This immersive media experience design lab is particularly looking into the design and research explorations in domains of virtual reality, augmented reality, mixed reality, VR filmmaking, and all those domains that connect these different technologies. So it's not restricted to only the education domain, but to various other domains. We also have a portfolio of works that are ranging from design and development projects to experimental projects, and those which are developed during the courseworks. And some of the works have also converted to academic publications. So all these sort of things are, part of this design lab. I'll quickly give you a demo, a glimpse of what all projects our lab has done, and then I'll move on to talking about specific to the education domain. Yeah, so moving forward, that was like a lot of projects have been taken up, but this we wanted to take up one project on education, and that was also concerned and collaborated with my PhD research. And to start with, we first wanted to understand what is the current role of technology in Indian school education system. So a lot of studies are there for the use of technology in schools abroad, but little is explored in the Indian context. So we wanted to understand deeply, like what is the current role of use of technology, be it in the urban scenario or in the rural scenario. So we went and looked into the different schools. We talked to the students, we talked to the teachers, and tried to witness and understand how the present classroom scenario is. So if you see in the pictures that are shared on this slide, so this is particularly referring to a few rural schools where this is explaining how the current sitting arrangement and how the students were learning in this way of infrastructure. But an interesting fact that came into our notice was, even if they are not that well supported with the infrastructure, technology was not something that they were very far behind from. So the teachers have been putting in effort, and the government has been supporting them in bringing up technology in the classrooms. So a few of the teachers uh, brought in their own mobile phones, brought in their tablets to showcase to the students the different topics related to this topics that were being taught to them, and they were showing it on their mobile phones. And a few of the schools were provided with tablets in which they had the video modules, which were showcased on the projector screens. So we looked into the schools of Maharashtra and also to a few residential schools to see how the use of technology is there. So they do have the computer labs there, which is being promoted among the students from class 10th onwards to use, and which is basically driving them towards more of the use of technology. And our lab was fortunate enough where we were supported by the Tata Center for Technology and Design at IIT Bombay. And also we were supported by Ananda Care Charitable Trust, who helped us in collaborating and coordinating with the different schools in the rural areas as well as urban areas. So with all the observations, our broader goal became to see if emerging technology like augmented reality can be brought forth in the STEM education for the target audience we chose was that of middle school students, and if this collaboration can be done in the Indian context. So this gave birth to the Scholar Project, in which the main idea was for us to investigate the effect of augmented reality learning for school students and to help them develop their spatial ability, and to provide them learning activities or the content which were beyond textbooks but help them in learning the context, which were examples of the applications in the real world, and which could be done in a very collaborated and peer learning way, which followed constructivist approach and help them in learning by doing. And the teacher should be acting as a facilitator and a reviewer, and the students get to be the active agents in the learning process. So we targeted the age group of 12 to 13 years, and we started our investigations with 7th standard students who belong to Maharashtra board. And we explored the topic of maths. And to dive deeper, we started with the topics of geometry. So I'll now talk about 3 case studies which were pertaining to this particular project, and to showcase how research evolved into the different genres that we wanted to look into. And also, we were particularly looking into how the learning activities need to be designed with connected interactions into that, and the content creation in a very deliverable and in a very simple form of understanding can be conveyed to the students, and how the interactions can be brought forth between the teacher and the student using that technology in the classroom itself. So we wanted the teachers also to be equally a participant in the entire learning process, and also the networking of the digital tabs, how these tabs need to be brought in together so that the students are collaboratively learning in the entire process, and how the locally downloaded content can be taken care of in the entire learning process. And we scaled it across from semi-urban schools to urban schools and across different boards of education and different subjects. Now I'll be talking about the first case study where we actually looked into the different AR interaction mediums, and how the students responded to that, and how their creativity evolved in case of using the interaction mediums. So we narrowed down to three types of interactions, that is draw and annotate, where the students could draw on the virtually on the 3D object that is projected onto their real world, and they can draw and annotate on that. And by the way, this is all that we are doing is using a tablet, and this uses the markerless AR technology, where the students need to first scan the space and a 3D object pops up. And on that, they do certain interactions and activities to go ahead with the learning process. Yeah, so to go ahead with again with AR interaction mediums, one was the draw and annotate, where they use their index finger to um, draw on the screen. The another interaction which we provided was for them to use the tangible cubes, which basically were the marker cubes, and that helped to interact with the virtual object that was showcased. And the third was the general tap and view, where they would do some certain interactions by tapping the fingers on the screen, and certain way of responding to that interaction would lead to certain actions happening. So this then helped us in investigating how the creative use of these interaction mediums can help them in answering a few open-ended questions, and how are they using their spatial reasoning skills while answering the questions. So broadly, this was the setup in which we were able to conduct the study with 12 students in a semi-urban school. And if you see, we had different groups, and each group had one researcher who was observing the entire process. We also had placed the different camera, three cameras on different corners of the room to capture the entire process of how they are doing. The main purpose for placing the cameras at the corners were that the students were not sitting only on the desk. They would move around the space to see the 3D object being projected on their tablets while they are still there in the classroom. So their real world environment was also there, on top of which their virtual object was getting augmented. So, and we wanted them to move around and interact with the object as they would do it in the real world scenario. So this task design basically involved them to do four tasks, which were pertaining to four different topics of seventh grade math. That is area, lines and angles, symmetry and congruence, and visualizing 3D solids. And for each of these topics, four different 3D models were given and four different tasks were given. So for area, they had to think of ways in which they could calculate the area. And for each of the different mediums could be used in answering those questions. For the lines and angles, they could think of the different methods to find the internal angles between two walls. These walls were not at a 90-degree angle, but at a odd angle of 120 degrees. So they had to find out ways of how they would think of finding the internal angles. Then they had to, for the symmetry and congruence, they had to think of ways to fill the structure with objects of any shape and size. And for visualizing 3D solids, they had to think of the ways they would climb the mountain in the fastest way possible. So all these were the different tasks that were given to them. And the methodology to conduct the study was that we followed the balanced Latin square design, where each group got to explore each of the activities and each of the interaction medium. And one was the control medium, where they were not given any medium. It was a basic paper pen medium where they had to solve the questions on the paper. So each of the groups got to explore each of these AR interaction mediums and the tasks. So this then gave us certain findings about how the students are interacting to solve the questions. There, we came up with certain interesting observations where we saw that in a group of three, there is like one person who is dominantly trying to answer, but the other two would somehow try to help that person to answer the questions, not in with the dominance, but with the logical response. So all those observations were interesting to look into. And from the interaction medium point of view, we saw that tap and view and draw and annotate mediums, these were almost equivalent in use, and the students were more comfortable in using this medium. The tangible cube did not work in a good way for them because of certain occlusion problems. So they were refraining in using it in a flexible manner. And also, group interactions and dynamics were actually helping the students in shaping the approaches to to solving the problems. And we also evaluated creativity in terms of how they were answering the questions. And for that, we evaluated using the Guilford's test of divergent thinking, in which we evaluated the three parameters, that is fluency, flexibility, and originality, where fluency meant the total number of answers that they were giving. And flexibility was to see how many categories or different ways in which the groups were thinking to solve the answers. And originality was to see among the groups how original were the answer or how unique were the answers. So this evaluation gave us a good view of how the creativity was seen across the group, across the task, and across the AR interaction medium. So only there was one group who outperformed in the creativity zone, where they were able to answer very frequent with a lot of new approaches and in a very impromptu way. And also the task in terms of the task, symmetry and congruence was the topic which led them in responding in a very creative manner. Also, in terms of using the AR interaction mediums, where they had to view, like use the tap and view medium, that was the one that helped them in imagining in a better manner. Okay, moving on. This is I'll now talk about a second case study, which is on implementing the topic of lines and angles in the augmented reality world. So we had two publications. If you want, you can dive deeper into observing like how the study was done and what outcomes came out of it. I'll just give a glimpse of the entire process of the study. So I'll show you a video of how the task was designed in this. Okay, I think it's taking time to buffer, but I'll show you a glimpse of the task. So if you see on the left side of this, there is an image where a 3D house pops up after scanning the space. So when you are scanning your real world space, a 3D house is popping up on that. And we had given the students three different activities, where the first activity was based on the problem solving method of repetition, where they had to try out multiple times to understand how what the different types of angles that are there. So in the first activity, they had to find three acute angles, right angles, and obtuse angles, and they could draw on the screen. So if you see the white markers that are there, so this is basically the angles that are drawn by hand on the 3D house. So that 3D drawing gets superimposed on that house. The second activity was a contextual problem in which a context was given to them and that had a specific answer to that, and they had to find and mark the angle for that. And the third one was involved breaking the problem into smaller problems. And another interesting scenario that was given to them was this house was not only something that one could see from outside. They were made to go inside the house, so they could actually move inside the house and see it from all corners. And then they had to pick up one window on which they had to find the interior angles of the triangle, and then tell the sum of the interior angles of the window. So this was the way we tried to to help them interact with the 3D virtual object that's there and actually make them involve into that environment. So the interactions that we define in this process involved firstly one finger tap with which they could draw the lines on lines or angles on the 3D house. Then with the two finger tap, they could zoom in and zoom out. We tried to keep it in the way it's actually being used nowadays on phones. So with the finger tap, they were able to zoom in and zoom out wherever they were from the plane, how far or closer they were placing, they were tapping on the screen. And with a three finger tap, they were able to erase whatever they were drawing. So we in this with this design we did two set of studies. One was in the lab setting and one was in the classroom settings, and we tried to analyze from the point of view of cognition, emotion, and social aspect of learning to see how the students were absorbing the designed activities and how they were responding to that. And for that we had certain procedure followed, which involved pre-test, post-test, then certain questionnaires of motivation and usability, and we also had semi-structured interviews. So this was the setup of this was the lab setting setup where we had called in students to our lab and we had given them the tablets, and the students in this particular one, there were few who were made to do the tasks individually and few who were made to do the tasks in dyads. So we observed how the pattern, like how the interaction behavior differed in case of using the tabs and this learning in AR space individually or in dyads. And this study was done in the rural context, in the rural schools, where all the students did it in dyads, and we also tried to introduce peer instruction to this learning methodology. And this was something which was new to them. They were not really acquainted to this entire augmented reality technology. So this was one challenge that came up for us. And if you see in this particular image, the one at the bottom and the middle one. So this is the way how this house was superimposed onto the real world. So if you see the mat is there, and on top of that, they are able to see the house getting superimposed. So on doing the study, we then tried to look into the learnability, likability, usability, the motivation of doing the learning activities, the visual spatial skills, and the interaction behavior. So I'll just quickly go through what all we observed in the process. So learnability wise, we wanted to see like how much time are the dyads taking in each of the activities and how much time are the individuals taking in doing the activities. Then what is the pattern of holding the tablets? Does that influence the way that they're trying to learn the topic? Then likability in terms of which activity they liked more, which they didn't like, and usability, for which we had given them the SIS questionnaire, that is system usability scale, and they had to answer accordingly in the Likert scale, and that helped us in deriving like whether the usability was more for the dyads or the individuals. We also looked into the learning outcome for these students in terms of individually performing and performing in dyads, and comparing the pre-test and post-test scores to see how the learning impact has happened overall for each of the group of students. We also evaluated the motivation of using Scholar for this IMMS questionnaire is there. So we used that, which helped us in evaluating the motivation across attention, relevance, confidence, and satisfaction scale. So we had given the questionnaire to the students. We explained them each of the sentences to help them understand what each of the statement means, and then they marked the value for each of those, which helped us in coming up with the value for the overall motivation. We also looked into what was the role of the visual spatial thinking, and visual spatial thinking was evaluated in terms of mental rotation, spatial visualization, and spatial orientation. And for each of the activities, we tried to see at what point any of these components was coming into play for every activity individually, and which was general to all the three activities. So at what point, which component of visual spatial thinking was actively being used by the students. We also tried to understand the interaction behavior with the students, for which we did the lag sequential analysis, in which we first brought a few codes to see how the peer involvement, the teacher prompts, and the AR interactions played a role in the entire learning process. So we watched all the videos of the dyads in the second study, and we tried to observe the pattern throughout. And the entire sequence helped us in coming up with the final sequence of what was the most dominant sequence in using the interactions, and what was the guiding one which helped them in performing the AR activities. So the observations that we mostly came up with, that the participants, specifically in the dyads, were helping each other to mark the angles by correcting each other wherever needed. So the interaction actually helped them in coming up with a better explanation of why a certain angle is being marked and how to mark that angle. Also, prompt some of the unintuitive interaction, like the scaling, was being prompted by the teachers, because they were mostly marking with one hand, but using the two fingers to zoom in, zoom out was something that the teachers had to prompt in sometimes. Otherwise, they were just moving forward or backward to do the zoom in and zoom out action. So they had forgotten, they were immersed into that interaction, that they had mostly forgotten that they can also use the scaling option. So this was in a way providing them to be more immersive in the way they are doing the activities, and they were actually forgetting the usual way of scaling using the mobile or the tablet mediums. And uh, third interesting fact that came into notice was that the feature of AR, explored by the ability to move around the house, was something that was often in use. Like the way I said it for the scaling option. So they were mostly moving around the house from all the sides to do all kinds of interactions. So physical interaction, physical movement was something that enhanced in the entire process, which was actually helping them in discuss and mark and see it from the different perspectives, the different angles. Okay, so these were some of the findings from the study, which looked specifically into the lines and angles topic. Then another topic that we are looking into is visualizing solid shapes. So this is the initial activity that we had designed. Now we are coming up with the different iterations. So I'll just talk about this iteration that we had done. So again, we had 6 different activities, where first they explore the different shapes, and then we are giving them the different shapes to look into, and the different problems, questions to solve. So this was the entire setup when we had given it to do it in the school actually. And these were some of the points that we looked into, that is the visualization skills, their perception of learning, their usefulness of the application, and the challenges that they were facing in using. So these were something that we obtained from while interviewing the students who had used this application. And we also got to see the learning impact. We had given them again the pre-test and post-test questionnaires, which helped us in obtaining how this impacted their learning. We also gave teachers the task of card sorting, where we wanted to understand how they observe the flow of the entire application that we are giving in the school. So we did one workshop with the teachers, and the card sorting was something that we explored with them. And we also gave them the demo of the application that we were designing. And we then were able to come up with a broader framework for our application, where we defined it according to different stages, where stage 1, we say we give them the activity for AR exploration. Then in stage 2, we give them a learning activity, which is particularly something that they do on their own or with the help of the partners. And in stage 3, we give them reflective questions to see how they have absorbed the learning. Apart from that, this is the last one that I'll talk about. This is something that we are still looking into. This is a Scholar Remote project, which of course started once this pandemic came in. Um, I'll give you a demo of what is being done. So, in this one, we are particularly trying to look into the different directions of seeing how the applications to education for this particular implementation can be done, and how do we evaluate the social presence, which is basically the extent to which a user feels that another person is actually present in the shared virtual space. And we are trying to investigate the different interaction techniques in the process, and also the different representations of the avatars that are there. So how the hair, hands, or the different representations can be used in the entire process. So yes, broadly, these are the projects and the factors that we are working upon. So I think I'll end this presentation here.